I'm Miss Gonyea.
And I'm Miss Blumenfeld. And today we're going to do some experiments involving elephant toothpaste.
The first experiment we're going to do, we're going to alter the concentration of hydrogen peroxide, keeping the container the same. We're going to measure the time it takes to fill the container with the hydrogen peroxide and oxygen reactant.
For our second experiment, we're going to see how the total volume of the cylinder affects the time it takes to completely fill the container.
Now we're going to discuss the materials that we will need for this lab. First, we're going to use 3 different sizes graduated cylinders. Then we're going to use 3 different concentrations of hydrogen peroxide. Here we have 3%, 6%, and 12%. We're also going to use dish soap, some food coloring to be able to see our experiment. We have some yeast that we got at the store. This is going to be the catalyst for our reaction. We're going to pour that yeast in some warm water, so we have a beaker and a spoon to stir it up. We also need a ruler to measure the height of the graduated cylinder as well as the radius. First, you're going to need your safety goggles or glasses to protect your eyes from the hydrogen peroxide. You're also going to need gloves to protect your hands from the higher concentration hydrogen peroxide. We request that you wear closed-toed shoes to protect your feet, and if you have longer hair, to tie it back using a hair tie, as long as it's out of your face. And now we're going to look at the chemical reaction. So we have hydrogen peroxide going with the catalyst. Yeast is going to speed up the decomposition of hydrogen peroxide into oxygen and water. But now we have to balance the reaction. So to do this, we divide the equation into the left side and the right side. So on the left-hand side, we have 2 hydrogens, H2. We also have 2 oxygens. On the right-hand side, we have 2 hydrogens, and we have 1, 2, 3. We have 3 oxygens. Now the hydrogens are the same, but the oxygens are different. So we need to change the coefficient. So let's try this. We'll change this to 2. So 2 times 2 is 4, so that gives us 4 hydrogens on this side. And 2 times 2 is 4 as well, and that gives us 4 oxygens on this side. So now we have to change this side and try to make it match. So we'll try 2 here. 2 times 2 is 4, so we have 4 hydrogens, which match. Then we have 2 times 2, or 2 plus 2, so we have 4 oxygens. Now we're balanced. We have the same number of elements on each side of the reaction for it to occur. So, in the end, we have, for each mole of hydrogen peroxide, we have 2 moles of hydrogen peroxide going down to 2 moles of water, 1 mole of oxygen. So now we're going to look into the concentration of each hydrogen peroxide solution. So the first one we're going to look at is 3%. This is the kind of peroxide that you put on your cuts and scrapes to get rid of bacteria. So 3%, it's a 3% weight per volume. That's another way of writing concentration. So what does that mean exactly? Well, for every 3, you're going to have 3 grams of hydrogen peroxide for every 100 milliliters of solution. Same goes for 6% and 12%. 6%, you have 6 grams per 100 milliliters of solution. And 12, you're going to have 12 grams per 100 milliliters of solution. So as we move from 3% to 12%, you're getting more concentrated hydrogen peroxide. Now, hydrogen peroxide can be corrosive in high concentration. For instance, 12% hydrogen peroxide is used to bleach your hair. Same as the 6%, this does a similar thing. Now we're going to do the experiment where we change the concentration, but we're going to keep the volume of the cylinder the same. So first we're going to use 3% of hydrogen peroxide and add it to the cylinder. We're going to time the time it takes for the reaction to reach the top of the cylinder. We will do this for each of the concentrations. First, we dissolve some yeast in about 2 tablespoons of warm water. Then we mix it up to form a slurry. Next, we're going to add approximately 100 milliliters of hydrogen peroxide to the graduated cylinder. Next, we will add a few drops of soap to our graduated cylinder. Then we're going to add a couple drops of food coloring to our experiment. Finally, we will add the yeast mixture to start our reaction. Now we're going to do the 6% hydrogen peroxide concentration. Finally, the last part of this experiment, we're going to do 12% hydrogen peroxide and see how this changes our results. So today in our experiment, we're going to estimate the total volume of each one of these cylinders and see how long it takes for the concoction to reach the top of the cylinder. So to do this, we have to find the volume, which is the equation pi equals r squared times h, where r is the radius and h is the height. So we have to find the radius and the height for each one of these cylinders. We will first find the height of the cylinder by laying the ruler as so, and to find that it equals 9.5 inches. We will next find the radius by first finding the diameter. We will lie the ruler across as so,
to find that the diameter equals 1.25 inches. Now that we know the radius and height of each of the cylinders, we will use them to plug them into our equation as such. We now plug these into a calculator to find the volume. We now have the volume of all three cylinders. We must use this to see how the volume of the container changes the time it reaches for the container to reach capacity. We will first use the largest cylinder, the 1,000 milliliter cylinder. Now we will do the 250 milliliter cylinder, the middle cylinder. Lastly, we will do the experiment with a 100 milliliter cylinder. So as we can see from our results, as the concentration increased from 3% to 12%, the amount of time it took for the reaction to occur decreased. When we did the 3%, it didn't go all the way up to the top. So we stopped the time at 88 seconds. In conclusion, as the concentration increased, the reaction occurred faster, and the time that it took for the reaction to go to completion or reach the top of the cylinder decreased. The slope of the graph is negative 0.081. So we can see as the concentration increases, the time decreases from the slope. In our second experiment, we saw how the total volume of the cylinder affected the time it took to completely fill it up. As you can see, the higher the volume, the more time it took to fill up. So for our largest, we have 7.95 seconds, and for our smallest, we have 4.82 seconds. We can start a graph using this information. We know that the slope equals 21.9. This shows that there is a direct relationship between the volume and the time it takes to fill up the cylinder. If we compare the first and second experiment, we see that the volume has a more direct relationship with the time than the concentration does.
So thank you for watching. We're really glad you could join us tonight.
Join us next week for another exciting experiment. Have a great one!